Yes. Suppose we are working over a field Galois field p raised to power m. Okay, which is nothing but something like Galois field with q number of elements, and I want to factor x raised to power p raised to power m minus 1 minus 1. How do we factor this? So in order to factorize this polynomial, what we do, we consider integer modulo p raised to power m minus 1, and we decompose it into cosets, the cyclotomic cosets that you saw in the last class. So let us take an example here so that you can understand. So suppose p is equal to 2 and m is equal to 3. So that means we are looking at Galois field with 8 number of elements, which is nothing but Galois field 2 cube. Okay. Now, so that means we have to divide integer modulo 7. We have to look at modulo 7. Okay. Cyclotomic coset C0. C0 will be singleton 0. Okay. And then you multiply it with 2, which is a prime. You again get the same thing. So next one is C1. So you take 1, multiply it with 2, modulo 7 will remain 2. Then multiply it with 2 again, it will be 4, modulo 7. Now you multiply with 2 and modulo 7, you get 1. So this is closed. Now 0, 1, 2, 4. What is left is 3. So we start the next cyclotomic coset with C3. C3 is starting from 3. Multiply it with 2, we get 6. So 3 into 2 is 6. Okay. So we write it 6 modulo 7. And then 6 into 2 is 12. And modulo 7, that is nothing but 5. And then if you take 5 and multiply with 2 again, so modulo 7 you will get 3. So we are back to C3. So this is how we decompose this into cyclotomic cosets. Now these cyclotomic cosets, as you know, so basically we want to factor x raised to power p raised to power m minus 1 minus 1. So in our case, we want to factor x raised to power 7 minus 1. How do we factor this? If we want to factor this polynomial, so first we need to look at cyclotomic cosets. There are 3 of them. Fine. Now I will make conjugacy classes. So basically the first one will be trivial one, which of course we are not considering, it is 0. Maybe I just write it like this here. Conjugacy classes. And I will write down minimal polynomial. So when we take 0, we will get minimal polynomial as x. When we take alpha raised to power 0, you know, basically I am taking this power here, which is nothing but 1. So minimal polynomial is x plus 1. Okay. X plus alpha raised to power 0, which is 1, x plus 1. Next, we know that cyclotomic cosets are 1, 2, 4. So we have alpha, alpha square, and alpha raised to power 4. Okay. And so minimal polynomial in this case will be x plus alpha into x plus alpha square into x plus alpha raised to power 4. What is this value? I will actually compute in a minute. And the next one is alpha raised to power 3, alpha raised to power 6, alpha raised to power 5. So this will be x plus alpha cube, x plus alpha raised to power 6, and x plus alpha raised to power 5. Okay. So now let us compute The second one, x plus alpha into x plus alpha square into x plus alpha raised to power 4. This can be written as x square plus alpha raised to power 4 x plus alpha cube into x plus alpha raised to power 4. Now we have to keep in mind that all the for constructing field with 8 number of elements, suppose we are taking the polynomial is x cube plus x plus 1 is equal to 0. So we have alpha cube plus alpha plus 1 is equal to 0, and also we have alpha raised to power 7 is equal to 1. In other words, I'll show you. uh, you know here is the field, field with 8 number of elements. The polynomial is 1 plus x cube, and so there is a power representation of the field element 0 1 up to alpha raised to power 7. This is a power representation, then the polynomial representation, and the theta representation in terms of bits. I can represent 0 as 0 0 0, 1 as 1 0 0, alpha as 0 1 0, and so on. So from this, we know what is the value of everything. When we do every arithmetic keeping these things in mind. So suppose I have to add alpha square and alpha cube. So alpha square plus alpha cube will be adding these two things actually, and we are going to get alpha raised to power 5. Okay, so this is how we do all the addition and multiplication. Okay, keeping this thing in mind. Okay, so that's how we computed this, and when we expand it, it turns out that this value is nothing but x cube plus alpha raised to power 4 plus alpha raised to power 4 times x square plus alpha raised to power 8 plus alpha raised to power cube times x plus alpha raised to power 7. Alpha raised to power 7 is 1, so this turns out to be x cube. This is 0. Okay, this portion is 0. X cube plus x plus 1. So our minimal polynomial, and we denote this by notation m1 of x. And the reason is clear, because this power is 1 here. So in fact, this is also known as polynomial of 2 of x, or this is same thing as minimal polynomial of 4 of x. So same thing, all these minimal polynomials are same. Okay, so keeping this in mind, so we know that minimal polynomial m1x turns out to be minimal polynomial wait a minute, m1 of x is equal to x cube plus x plus 1. Okay, now we know that if alpha is primitive element, so is alpha inverse is also primitive element. So now we know that alpha square and alpha is power 4, these are the primitive elements. So alpha minus 1 will be what? Alpha raised to power 7 minus 1, which is nothing but alpha raised to power 6, right? Alpha minus 2 will be alpha raised to power 7 minus 2 is equal to alpha raised to power 5, and alpha raised for minus 4 is nothing but alpha raised for 7 minus 4 is nothing but alpha cube. So we get the second set, which is alpha raised for 3 comma alpha raised for 5 comma alpha raised for 6. You see the second thing from the cyclotomic coset, we are getting this, right? So if these are the primitive elements, they're inverse. So basically inverse of alpha raised for 1 is nothing but alpha raised for 6. Alpha raised for 2 inverse is alpha raised for 5. And inverse of alpha raised for 4 is alpha raised for 3. Right? So these are inverses of each other. Also, so basically I can now consider the minimal polynomial of alpha cube, m3 of x, which is same thing as m5 of x, which is same thing as m6 of x, will be x plus alpha raised for 6 into x plus alpha raised for 5 into x plus alpha raised for cube, and we can compute in the same manner. The value is x cube plus x square plus 1 by keeping all the arithmetic of field with 8 number of elements. Moreover, now I would like to show you another beautiful result. If px is a primitive polynomial, so is p star x, right? Which is x raised for m times p of x inverse. So now in our case, if we take px to be x cube plus x plus 1, so what is p star x? X cube times x raised for minus 3 plus x raised for minus 1 plus 1, which is same thing as 1 plus x square plus x cube, the other polynomial, right? So it turns out that x cube plus x square plus x is a reciprocal polynomial. This is nothing but the reciprocal polynomial of x cube plus x plus 1. So this is an interesting relationship, right, between field and its primitive elements, and so the overall factorization of x raised for 7 minus 1 will be, for the first factor will come from x plus 1, this one, this cyclotomic coset, then this one and this one. So here we have x plus 1, then x cube plus x plus 1, and x cube plus x square plus 1. This is the factorization of x raised for 7 minus 1. Now if we want to include the first factor as well, so the whole thing can be written as x raised to power 8 minus x is equal to x times x plus 1, x cube plus x plus 1, and x cube plus x square plus 1. So this is how we find the factorization. I have shown you for the field with 8 number of elements, and I would like you to do the exercise for field with 16 number of elements. So I'll show you the arithmetic. So field with 16 number of elements. Number of elements, we need to find out the factorization of x raised for 15 minus 1. This is known, right? This you want to find it out. So actually, again, we need to look at the cyclotomic cosets and so on. let me show you the field. So we need to take, say, one polynomial. I can take x raised to 4 plus x plus 1 is first polynomial, to compute the field arithmetic. Or you can take the other polynomial, whatever. I mean, you can take any one of the polynomial, or you can take x raised to 4 plus x cube plus 1. Both are irreducible polynomials, and you can use them to construct the field. This I have shown you with respect to 8, and I will show you with respect to 16. So 16, actually, you can see that the arithmetic will be like this. If I take the polynomial x raised to 4 plus x plus 1 as a irreducible polynomial, I can actually write down the power representation, polynomial representation, and the 4-tuple representation of the field with 16 number of elements. So using this table, we can do the arithmetic quite quickly. We note that alpha raised to 15 is equal to 1 here, right? And if you form the cyclotomic cosets, the conjugacy classes are 0, 1. So the cyclotomic cosets will be 0, 1, 2, 4, 8, 3, 6, 12, 9, 5 and 10, 7, 14, 13, 11. So these are the powers of alpha, and I can compute the basically minimal polynomials for each of them. Okay. So as you can see that alpha square, alpha is for 4, alpha is for 8. Order of each element here is 15. Okay. So that's why you see this polynomial x raised to 4 plus x plus 1 and x raised to 4 plus x cubed plus 1 are used to construct the field GF16. These polynomials are not going to work. Okay. So these are primitive polynomials as well. So I think it is clear to you what are the primitive polynomials, what are the minimal polynomials. I leave as an exercise to verify all these facts for field with 16 number of elements. Now I think I can just mention some general results in this regard, which should be useful for you. I've already shown you the theory, but definition of mankg, which I have used here, minimal polynomial. So mankg is nothing but minimal polynomial of alpha raised for I in field with p raised for m elements. Okay. So by definition, we know that by M6 property from the previous class, MPIX will be same thing as MIX. Okay, this is a property here. Now, if I belongs to member of cyclotomic coset CS, cyclotomic coset, cyclotomic means circle cutting, coset containing S in GF p raised for m, then we know that partial product J belongs to CS x minus alpha raised for J. The polynomial that we computed will divide MIX. Right? In fact, we have much more to say, and that is your 7th property says that MIX is nothing but partial product J belongs to CS x minus alpha raised for J. We just found the polynomial, like for example x plus alpha plus x plus alpha into x plus alpha square plus into x plus alpha is for 4, right? This is this minimal polynomial, right? And hence this implies that x raised for p raised for m minus 1 can be written as partial product over s m s x cyclotomic coset. Okay, where s runs through coset representative modulo p raised for m minus 1. Okay, and hence, x raised to power q minus x is nothing but product of all monic irreducible polynomials over GFP whose degree divides m. This is the main result of the factorization. Okay, so I think we have shown you by examples these finite fields. I'll just mention a few more, and I think that will be all for today. Okay, so there are a few more properties which I'd like to mention here. First one is that Galois field with p raised to power r elements contains Galois field with p raised to power s elements if and only if s divides r. This is something very important. Another interesting lemma. In any field, x raised to power s minus 1 divides x raised to power r minus 1 if and only if s divides r. Right. These are some very basic properties. So I think that's all for today. In the next class, we are going to start Bch codes. So this machinery is sufficient for us to give you the basic definition of Bch codes. Bch codes are known as mother of all block codes, and very useful because BCH stands for Bose Chaudhary Hockingham codes. They are quite interesting in a sense that whatever error correcting capability you want in your codes, you can actually design them. So it's really a powerful construction. It's a generalization of the idea of the Hamming code. So we look at the paired matrix of the Hamming code and we add extra rows into it so we know that Hamming code can correct single error, right? So we add more rows so that we can correct 2 errors. We add more rows so that it can correct 3 errors and so on. In general, if you want to correct t errors, so we know how to construct the code. So this is a very powerful and nice idea. And later on, we will see that, many of the important codes are a special case of BCH codes, So that's why these are known as mother of all block codes, So block codes. Okay, so this is something very, very important. So that's all for today. In the next class, we will look at the BCH code.